A deep dive into sklearn's Gaussian process classifier. The Gaussian process classifier in scikit-learn is a powerful tool for tackling binary and multi-class classification problems. It leverages the probabilistic framework of Gaussian processes (GPs) to offer not just predictions, but also a measure of uncertainty associated with those predictions. This makes it particularly attractive for situations where understanding the confidence in our classification is crucial. Let's break down the key aspects. 1. The essence of Gaussian processes. Probabilistic model. Unlike traditional classifiers that output a single prediction, GPs work with probability distributions. For a given input, the GP defines a Gaussian distribution over possible output values. Kernel function. The heart of a GP lies in its kernel function, which captures the relationships between data points. This function determines how similar two inputs are, influencing the resulting probability distribution. Different kernels represent different assumptions about the data. Prior and posterior. A GP starts with a prior distribution over the function space, representing our initial beliefs about the underlying relationship. Through observed data, this prior is updated to a posterior distribution, capturing the learned knowledge about the function. 2. Gaussian process classifier in action. Model training. During training, the classifier learns the parameters of the chosen kernel function by optimizing it on the provided data. Prediction. For a new data point, the GP predicts the class probability for each class label. It uses the learned kernel and the existing training data to create a Gaussian distribution over the class probabilities. Uncertainty quantification. The width of the Gaussian distribution reflects the uncertainty in a prediction. Wider distributions mean higher uncertainty, indicating a less confident prediction. This information can be valuable for decision making. 3. Key parameters and considerations. Kernel. The choice of kernel is crucial. Common options include RBF. Kernel radial basis function assumes smoothness in the data. Matern. Kernel offers more flexibility in controlling the smoothness assumption. Linear. Kernel suitable for linearly separable data. Optimizer controls how the kernel parameters are learned during training. Common choices include FMINLBFGSB and FMINCG. N. Restarts. Optimizer determines how many times the optimization process is restarted from random initial parameter values to avoid getting stuck in local optima. Random state. For reproducibility, sets the random seed used for initialization. Multiclass specifies the strategy for handling multi-class problems. Common options are 1 vs rest and 1 vs 1. N-jobs enables parallel processing for faster training and prediction. 4. Applications and advantages. Handling complex relationships. GPs can effectively model nonlinear relationships in the data. Uncertainty estimation. The inherent probabilistic nature of GPs allows for quantifying uncertainty in predictions, leading to more informed decisions. Flexibility. GPs are highly flexible and can be adapted to various classification problems by selecting the appropriate kernel. 5. Challenges and limitations. Computational cost. Training GPs can be computationally expensive, especially for large datasets. Sensitivity to hyperparameter choice. Choosing the right kernel and its hyperparameters is crucial for model performance. Scalability. Scaling GPs to very large datasets can pose significant challenges. 6. How to use Gaussian process classifier. Python. From sklearn, datasets import load iris. From sklearn, model selection import train test split. From sklearn, Gaussian process import Gaussian process classifier. From sklearn, Gaussian process, Kernels import RBF. Load the iris dataset. Iris load iris. X iris. Data. Y iris. Target. Split data into training and testing sets. X train. X test. Y train. Y test train test split X. Y. Test size 0.2. Random state 42. Define the kernel. Kernel RBF length scale 1.0. Create the Gaussian process classifier. CLF Gaussian process classifier kernel. Random state 42. Train the model. CLF. Fit X train. Y train. Make predictions on the test set. YPREDCLF. Predict X test. Evaluate performance. From sklearn, metrics import accuracy score. Accuracy score test. YPRED. Print accuracy. Conclusion. Gaussian process classifier in scikit-learn offers a powerful approach for classification problems. Its ability to provide probabilistic predictions and uncertainty quantification makes it particularly valuable for applications where confidence in the classification is critical. However, understanding the key parameters, potential limitations, and computational aspects is essential for effective use.